Everybody. Uh, 13.7 day 2 is going to be a lot of the same old stuff. So most of this is going to be review. I don't know if there's going to really be any new material. So if you want to go ahead and give these a try, I'm going to kind of go through them one or two at a time. The first two are going to involve our three dimensions. Pay close attention to the second one. That's one where I think we had a couple of difficult times with understanding how to plot a point in three dimensions, especially when there were negatives involved in the x direction. So go ahead and give those a try. I've made sure that I reminded you guys here what the distance formula is in three dimensions. So if you want to press pause and try the first two, when you unpause, I will have the answer to the first one, and then I'll probably go over the second one with you, just so you can hear my thought process as I work through that one. All right, so for this first one, we should get square root of 42. Now notice I did not x2 minus x1, I did x1 minus x2, and then y1 minus y2. It doesn't really matter, as long as you're really careful with your negatives, and when you have minus and negative, it becomes a plus. If you have a negative that you're squaring, you have to make sure, if you're using your calculator for that, you recognize that's a negative times a negative, your answer is positive. Those are the keys when you're using the distance formula, whether it's in 2 dimensions or 3 dimensions. All right, taking a look at this sketching of a three-dimensional point. So I'm going to use a light blue color to kind of walk our way through this. But first, I have to go -2 in my x direction. So -2 in my x direction, I'm assuming this is the positive x direction, which means I would have to go 1, 2 units back, and that puts me here. Now, I'm going to continue from that point to plot my y coordinate. -3 in my y direction, I am assuming to the right is positive y. I'm going to, from this point, go 1, 2, 3 units over this way. And now I'm here. A lot of people have been taking that y coordinate and going 1, 2, 3 and saying that's -3. Okay? And so they're putting their point here. But that's actually -5. You have to think three-dimensionally. The x-coordinate went back, y-coordinate goes back. Now, from there, I can go up 1, 2, 3, 4, 5, 6, 7, 8 units, and I can plot my new point right here. That's the ordered pair, -2, -3, 8 in 3 dimensions. All right, and the last one on this side is finding a coordinate in 3 dimensions. So it's again a distance formula problem, but this time I gave you the distance. You have to find the z coordinate for one of your ordered triples. Go ahead, pause, and try this one if you haven't already. All right, a lot of work to do here. So kind of walking through, we have to first set up our distance formula. And then when I square both sides, I can get rid of the original square roots. But that doesn't get rid of or change anything inside. Doesn't change the 138 or any of the operations inside. So here's a big algebra lesson. So we get the 138, and then we get our 25 from 12 minus 7 squared, or 7 minus 12 squared, still going to give us 25. -1 minus 6 squared is going to get us 49, or 1 minus -6 squared is going to get us 49. And then it's 4 minus z squared, or z minus 4. Either way, we're going to end up at z squared minus 8z plus 16. So you have to make sure we realize when we do 4 minus z quantity squared, that's the same as 4 minus z times 4 minus z. I think that's an area where a lot of students make mistakes when we are multiplying binomials or squaring binomials. And then we have to use the distributive property here. Okay. Get my quadratic equal to 0, solve my quadratic. We have 2 solutions. Just a couple more problems here, and these ones are definitely a little bit tricky as well. So make sure you pay close attention to the details here. So what you're being asked, sketch things out. I know the circle problem at the end might have some circles already sketched out for you. If not, make sure you're drawing your circles and understanding what the question is. Press pause and try number 4, please. On this one, I've kind of got it set up. So this is the hypotenuse, and the altitude from the right angle is going to intersect here at 6, 2. So what I know is that altitude, the vertex for the right angle is going to be somewhere on my dashed orange line. And what you have to realize is, how are we going to find where that is? Is it here? Is it up here? Where exactly is that located? See if that helps for those who have struggled a little bit so far. Hint number 2, this is the next helpful piece of information that's going to help you draw your conclusions. We know this section is 3, we know this section is 9, and the altitude forms a right angle, and we're going to have another right triangle up here somewhere. That's our next really helpful piece of information. We should be able to find the length of the altitude with this information. We do find, remember, we have the right triangle with an altitude from your right angle. We can identify our formula here. Applying that, this altitude squared is going to be equal to 3 times 9. The altitude will have a length of 3 root 3. That means that if I'm going to plot a point here, I have to go either up 1, 2, 3 root 3 units, so somewhere up in a little bit beyond 4, beyond 7, because 3 root 3 is really 5.2-ish, and so I would have to go 5.2 units above where I already am to get a length of about 5.2 units, which would put the vertex here to form my right angle. And that coordinate is going to be an x-coordinate of 6, and the y-coordinate is going to be 2 plus 3 square roots of 3. But that's only one possible answer. Okay? We also have the option of going 5.2-ish units below and having that right triangle come down here. That would also be a right triangle. That would also be an altitude that has that same length. So in this case, I can change this. It's not just 2 plus that, it's 2 plus or minus 3 root 3. But certainly not least, we skipped from, I think, 4 to 6. I'm not sure how the numbering happened there. But regardless, here's what we're looking at. We've got a circle represented by this equation and a second circle represented by this equation. And we need to use those to find the length of the common external tangent. Here is our common external tangent. We need to know its length. So this is bringing back a lot of stuff from our circles unit, as well as we're going to have some distance formula and some coordinate stuff here as well. Go ahead and press pause and try this one. So we've got this set up to start. The radius of the bigger circle is square root of 52, but that can be simplified to 2 square roots of 13. The radius of the smaller circle is the square root of 13. And remember, I can take that common external tangent here and drop that straight down because our radii and our tangent are perpendicular, straight down that radius, and it is also going to be perpendicular to this longer radius. It's perpendicular to the shorter radius as well, but I've now formed a rectangle up top and a right triangle at the bottom. Because I've formed a rectangle up top, the shorter radius is square root 13. The opposite side is also the square root of 13. And since the whole thing is 2 square roots of 13, right triangle tells me this is also the square root of 13. So now I know one side length. If I knew a second side length, I could use Pythagorean theorem. I could come up with other ways to identify the length of x here. And that's going to come from knowing the fact that the centers are at, in this case, -9, 4, and in the smaller circle, 12, 3. Knowing that information, I am now able to use the distance formula to get the distance between the centers. If you haven't done that, pause and try that now. formula gets me square root of 442. I could try to simplify it, but at this point it's not necessarily worth it because I'm going to just use the Pythagorean theorem anyway. So if you haven't already, you have one side, you have the hypotenuse, you need the third side of your triangle to get the length of your common external tangent. Finally, the Pythagorean theorem has given us a distance of square root of 429. As always, if you have questions, please do not hesitate to send me an email. I look forward to hearing from you guys. I will try to set up a Google Meet this week as well, so hopefully we get a chance to see each other again, even if it is virtually. Take care.